Littleton, Colorado, March 2011. At Lockheed Martin's Waterton Canyon facility, NASA's Juno orbiter is being assembled just weeks before its launch to explore the fifth planet from the Sun, Jupiter. Many scientists believe that the large moons orbiting the biggest planet in our solar system may be the best place to find life in outer space, and one day host humans as well. But to have any chance of exploring these moons, we must understand the giant beast that guards them.
Jupiter itself is one of the gas giants. It is practically the gas giant. It makes up most of the mass of our solar system outside of the Sun.
Jupiter's gravity is so strong that it acts like a cosmic vacuum cleaner in a way, stripping asteroids, rogue worlds, and swallowing them up without even blinking. In 1994, there was a comet, Shoemaker-Levy 9, that smashed into Jupiter, and it was strung into pieces before it hit. And each of those pieces exploded, creating a mushroom cloud the size of the Earth. And Jupiter didn't notice.
Jupiter's immense size and gravity also creates its greatest threat to human life: radiation.
Jupiter is spinning really fast. It's moving a lot of material around in its magnetic field. It's bombarding its moons and other areas with all of this radiation. And so for any human being, Jupiter would be a horrendous place to live.
The punishing effects of Jupiter's radiation was a top concern for scientists and engineers as they developed the Juno space probe in the early 2000s. Could a spacecraft be built that could withstand Jupiter's powerful wrath?
Jupiter, with its massive magnetic field, collects particles that fly by it and get generated by its moons. And then it speeds them up with its magnetic field. And then it has these belts of high-energy particles, radiation, that are just there. Electronics that we develop and build are highly susceptible to damage or upsets from that radiation.
The Juno mission is really the first mission to Jupiter to stay there for an appreciable amount of time. All the other missions were simple flyby missions, one shot and you're done. You really do need to be prepared for the radiation environment, and it really will affect the memory on board the spacecraft, and you really will have to come up with ways to work around that.
And so, as the Juno spacecraft nears completion, everyone at Lockheed Martin is on edge. The craft must be built and operated perfectly if it is to survive. But now, just weeks before launch, the craft has a serious problem. And the team in charge of Juno's construction is running out of time.
The biggest challenge we had was one of the avionics boxes. We were doing the last test in thermal, and the worst thing happened that you could have happen on a box, which is it was running well, it malfunctioned badly for 5 minutes, and then it started working fine again. You got to understand why that happened to make sure it's not going to happen again in the mission. I didn't know what we were going to do. So we thought it over, and I recommended to let us keep trying to solve the problem for a month or two. Thankfully, in the end, we figured out what happened. We were able to fix it, and then we were able to get that box to the spacecraft. Literally, we gave it to him on a Monday night. It was on the spacecraft Tuesday morning. It was in the final environmental test on Friday type of thing. If we would have not solved that problem successfully, I'm not sure if we would have made the launch date.
On August 5th, 2011, Juno successfully launched and began its 5-year journey to Jupiter. Remarkably, the probe survived its encounter with the giant planet, and in 2016 began its assignment to collect data on Jupiter's thermal radiation, gravitational and polar magnetic fields, and the circulation patterns in its atmosphere.
Before Juno, the poles of the planet were something we had never seen before. And so it was a mystery to the science community as a whole as to what was going on up there. And so Juno has flown across those poles and uncovered new mysteries of what is causing the swirling storms that we see in the images and just the makeup of the planet.
The incredible first ever pictures of Jupiter's poles showed giant swirling storms, similar to the famous Great Red Spot near Jupiter's equator. The spacecraft also got a look beneath these giant storms, but what it found was troubling, to say the least, especially if you were a human thinking about taking a look around.
Juno discovered that the Great Red Spot is enormously thick. We're talking around 200 miles deep. Compare that to the biggest storms on the Earth, which are only a few miles thick. This thing is a monster. If you plunge yourself down into the depths, you quickly experience pressures and temperatures beyond anything you could possibly imagine on the Earth. It is just a rough place to be.